And I'm here today on behalf of my colleagues Omar, Doukari, and Pablo Martinez. And this talk about digital twin-based operational resilience assessment in construction waste management during building renovation. And before I get into the digital framework and the digital details, I want to talk about the core issue of construction waste. So the construction and demolition activities generate about 35 to 40% of all EU solid waste. However, the current construction waste management practices are broken. We often plan and optimize our projects for time and cost, not for waste. And always waste is quantified at the project level, not at the activity level. So we don't link waste to activities or the project schedule. Also, there is no quantitative resilience indicators that can tell us when the waste stream is volatile or operationally risk. On the other hand, when we're talking about renovation makes this worse in terms of resident disruption, in terms of special constraint. In terms of special constraint, we may face a lot of challenges regarding limited storage, floor by floor access, and also the big stress days block access and create hazards. So this is an operational resilience problem, not just an environmental issue. So what does this study delivers to mitigate or address this issue? We have developed an integrated digital framework linking renovation scheduling to daily waste time series and resilience metrics. And we have developed two resilience indicators, Waste Volatility Index and the peak stress ratio, to quantify the construction waste operational stability. And we have investigated the effect of scheduling strategy on the waste generation resilience. And to achieve these objectives, we have developed a digital twin framework. The framework has 5 layers. The first layer covers the BIM model, renovation scope, site context, material quantities, and special constraint. And the second layer, in which we have defined the activities and developing the schedule based on performing work breakdown structure and including activity sequencing in considering production rate and the duration of each activity. And the third layer about waste quantification, in which we have used the quantities extracted from the BIM model plus the expansion coefficient to calculate the real volume of the waste based on different type of materials. And we have used the daily waste generated from the third layer to quantify the resilience indicators, the waste volatility index, and the peak stress ratio. And finally, we have developed a pre-designed decision support tool that enables automatic linkage between BIM, geometry schedule, and waste, which it is difficult to replicate manually at activity level across different renovation scenarios. This is the analytical core of the research. The two indicators, the two resilience indicators, the waste volatility index, which is represented by the standard deviation of the daily waste divided by the mean, to quantify how stable is daily waste generation, and also the normalized peak stress ratio to quantify when the waste will exceed the threshold. And we have tested our framework using a real residential building with 30 apartments with 5 floors and 1,120 square meters, and the building was occupied during renovation activities. We have developed a BIM model with a level of details 350, and we have developed a circular intelligent waste engine module to apply our approach. And we have run 3 scenarios to quantify waste volatility index and the peak stress ratio. Here we can see the 3 scenarios we have applied with different renovation scopes. The first scope covers the envelopes, the heat pumps, and the ventilation system. The second scope adds the same with mechanical ventilation with heat recovery. And the third scope builds on the second scope with insulation and solar. We have in the first scenario, we have used different scheduling strategies. In the first scenarios, we have performed between 4 to 6 activities in parallel, reach to the third scenario where we have performed 2 to 3 activities in parallel. And the duration of each activities, we can see here the first activity was 321 until we reach to the shortest one in the third scenario, where the total duration of the project was 317. And here's the core contribution of our research. We have developed a circular intelligent waste engine in which we have defined the activities and the zones of the building. And here we have built our work breakdown structure through selecting each renovation activities by zone. So you can here select the zone of activity, and here you can select the renovation activity. We also we have incorporated also the equipment used during renovation activities, because each tool has a unique generation production and also different waste generation. And this produces an activity zone matrix that help us to show the spatial distribution of renovation workers across the building. And also we have developed a precedence network to define the vertical and horizontal sequencing constraint. And the circular intelligent waste engine enable us to bridge the BIM model and the renovation schedule through considering both spatial and temporal integration. And the main output of our tool is the daily time series per activity, which will be used later to calculate both waste volatility index and peak stress ratio. And here are the results of the 3 scenarios. We can see here that the first scenario generates the maximum total waste volume with about 50 cubic decimeters, and also generates the maximum waste volatility index and peak stress ratio, while the third scenario give us the best resilience with the least values for both waste volatility index and the peak stress ratio. And we can see here also while the third scenario is the shortest one, but it gives us achieve the best resilience. And this tells us that the scheduling structure controls the waste behavior, not the project speed or the project duration. And here we can see the daily waste generation across the 3 scenarios. We can see here that the first scenario with the red lines, the peaks at about 377 cubic decimeter per day, and there is about 19 stress events during the first 20 days. And also the third scenario is more flattened. 1 minute. Okay, more flattened, and we can see here it is more flattened and with 0 stress events across the threshold. And here we can deduce that the curve shape is a product of how the schedule is structured, not about the project speed or the project duration. And finally, this is the resilience map, which show the waste volatility index against the normalized peak stress ratio. We can see here when we move to the left bottom, where the third scenario with the least values for waste volatility index and the peak stress ratio means better waste management resilience, and that is exactly where the scheduling structures enable us to do. And finally, to conclude, we have developed a digital twin framework that linking renovation scheduling to quantified waste resilience, and developed 2 resilience indicators to help us to quantify the operational resilience during building renovation. And we have deduced also that the scheduling structures matter more than the project duration or the project speed. And we have developed a pre-designed decision support tool that also help planners to and gives them a quantitative pay for scheduling decision. And regarding limitation, the results obtained in this approach are based on one single simulated case, and so we will need to validate and recalibrate it through multi-building. And in the future, we plan to use real waste data quantified from the site to validate our approach, and we will apply multi-objective optimization through considering other criteria like the cost associated with each scenario, and also quantifying the resident disruption to perform the multi-objective optimization. And this work is a part of the Marie Curie postdoc fellow at Northumbria University. And that's it. That's it for me today. And thank you very much for listening. I'm happy to take a question. Thank you.
Any questions?
Yeah, for sure. Yeah, go ahead.
How can your digital twin be updated during the construction?
Yeah, so I expect this question, to be honest. So